Alright, we're on page 238. This is called Using Exponents. This is a pretty important page to read carefully and then understand all the vocabulary and then understand the mechanics of how exponents work. So join me as we read this. A number that is formed by repeated multiplication of the same factor is called a power. You can use an exponent and a base to write a power. For example, 7 to the third power means the product of 3 sevens. So this term right here, 7 with a little raised 3, what that means is 7 times 7 times 7. There are no 3's in the problem. So what does the 3 mean? The 3 means that there are 1, 2, 3 sevens. Now let's learn all these terms. The 7 is called the base, the 3 is called the exponent, and the entire thing altogether is called the power. So the base is the 7, the exponent is the 3, and then all together it's called the power. Now how do you say those terms? There's different ways. Let's go look at our 3 examples here. We've got a 6 is the base and the 2 is the exponent. You could call that 6 squared. You could call that 6 to the power of 2. You could call that 6 raised to the second power. How about if it's the third power right here? That would be 7 cubed, or 7 to the power of 3, or 7 raised to the third power. 9 to the fourth power, that's 9 to the power of 4. 9 raised to the fourth power. Those are the ways that we say that. Alright, so let's check out how this works. Example 1 reads, use an exponent to write each expression. So what I do, I guess we'll read this and then I'll cover it up. A is 3 times 3 times 3 times 3 times 3. So it says find the base or the number being multiplied. The base is 3. It says find the exponent by counting the number of 3's being multiplied. The exponent is 5. And we're not computing an answer just yet. We're just writing what the problem is. So if I didn't have anything here and it said what is the problem, I would say there's a bunch of 3's. So the answer is 3 to the power of, and then I count them. 1, 2, 3, 4, 5. So no 5's in the problem, but the 5 here means that there are 5 3's. Alright, this one's going to look more complicated, but it's really not. It's a bunch of 4/5. If it's a bunch of 4/5 times each other, then the base is 4/5. And then you just count how many there are. There are 4 of them. The difference on this one is that you would need to put 4/5 into parentheses first before you raise it to the power of 4. It's a little bit hard to explain why, so you just need to trust me. When we have a fraction, we put the fraction as the base inside parentheses, and then we put the exponent outside the parentheses. Now we're not solving these yet. We're not going to solve these until the next page. At the bottom of this page, all we're doing, and you should probably try this, all we're doing right now is using exponents to write each expression. We are not solving. It doesn't say to solve each expression. It just says to use exponents to write the expressions. So what I want you to do is hit pause. I want you to try these 4 problems, and then when you think you got them, then hit play to check your answers. Alright, number 2 reads 4 times 4 times 4. We're not solving. We're using the exponents to write the expression. Well, the base is 4 because there's a bunch of 4's. And the exponent is how many 4's there are. There are 1, 2, 3 4's. The answer is 4 raised to the power of 3. Alright, number 3. It's one single 6. So it doesn't hardly seem like an exponent problem. If there's just one 6, the base is 6. And then the exponent is how many there are. How many 6's are there? There's just 1. So that's just 6 to the first power. Number 4. There's a couple of 1/8's. So the base is going to be 1/8. And we told you a minute ago from above that when you have your base as a fraction, we have to put that inside parentheses. And then we count how many there are. There are 2 1/8's, so the power is 2. And the last one is count them up. The base is 5, because there's a bunch of 5's, and just count 1, 2, 3, 4, 5, 6. So it's 5 to the 6th power. On the next video, we will learn how to solve. It's called finding the value. Okay, good job. You're done with page 238.